So this is just reviewing. You just had absolute value equations on your homework quiz. That was 1.4. So these are absolute value inequalities. So just like absolute value equations, yes. Oh, they were up here, sorry. Where did I just put that? Yeah, if you didn't grab a sheet when you turned your homework quiz in, anybody else need one? Paying my best attention to catch you if you didn't grab a sheet. Just like absolute value equations have the two cases. You have the positive case, the negative case, or that's how I refer to them. Absolute value inequalities also have two cases. So if we look at example 1, this is just kind of reasoning through why the solution sets are in the form that they're in. So it says solve each of these inequalities. These are the basic absolute value inequalities. Graph the solution set on a number line. So if we look at A, we have the absolute value of x is less than 3. So I'm actually going to make the number line first. I'm going to shade on a number line what values x could possibly be. So I'll put 0 in the middle here. So what is a value that x could be in order for the absolute value of x to be less than 3? So what's a value that x could be? That would be a solution to that. 2. What's another solution? 1. -1 and -2. Is 3 a solution? No. I'm still going to put 3 on here, but it's not. And then -3 is also not. But really any number, so this means the distance, absolute value again is the distance from 0. So the distance that x is from 0 has to be smaller than 3. That distance is smaller than 3. So that means if I were to graph this, I'm not including the -3 and +3 because those have a distance that's equal to 3. But any number that's in between them would be a solution. So this is what the graph of the solution set would look like on a number line. Hopefully that graph looks familiar to you from yesterday. So that would be the graph of a compound inequality. Would this be one that is joined by and or by or? And, yep, if it's shaded in the middle, kind of an overlap, it's a compound inequality joined by and. So if I were to write this as a compound inequality, these shaded values are bigger than -3, but smaller than 3. So this means x would be greater than -3, and x is less than +3. Okay, I'll just include the set builder around it. That's one way I could write it. We know if they're joined by and, we do have that condensed form, so you could also write it this way, that x is between negative and +3. That'd be an alternate form to write it in. Okay, but the key here is we had an absolute value inequality. The solution set is a compound inequality, and this one is joined by and. So if we look at example B, we have the absolute value of x is greater than 5. So again, if I start out just by graphing this on a number line, put 0 on there again. What are some solutions to this inequality? What are values that x could be? X could be 6. What else? -6. What else? 7. -7. So we could keep going. 8, -8. Again, the 5 and -5 would not be included. So I'm going to do this one a little differently. I'm going to put 5 and -5 on here. And they would not be included. But any number bigger than 5, so 6, 7, 8, that would be a solution because this means the distance x is from 0 has to be greater than 5, any distance bigger than 5. And then I also have any value that is less than -5. So this is also the graph of a compound inequality, but this one would be joined by or because they're not overlapping, they're shaded opposite directions. Ors don't have to be shaded opposite directions, but this definitely could not be an and because they're not overlapping. So this solution said if I were to write this, it'd be x values less than -5 or x values greater than +5. And remember, if you have a compound inequality joined by or, this is the only way you can write it. So I don't have that condensed form to write it in. For the set builder anyway, we do have the interval notation, but that would be the only form we could write that in. So one thing to realize here is when you have an absolute value inequality that contains the less than symbol, and it could be less than or equal to, your answer will be a compound inequality that is joined by and. And then when you have an absolute value inequality with a greater than symbol or greater than or equal to, it'll be a compound inequality joined by or. So the inequality symbol determines which word they are joined by, but your answer for both cases is a compound inequality. That's how it's tying into yesterday. So right here, what I just said, absolute value inequalities, we solve them by rewriting them as compound inequalities. So just like your absolute value equations, when you set up your two cases, we will do that same thing for absolute value inequalities, but you then have to determine with those two cases which word goes in the middle. Is it an and or is it an or? So, bless you. Down here, it's kind of laid out for you a little bit, and I'll go through examples of each. So again, if you have the absolute value of a quantity is greater than a number, then it's joined by or. And notice your two cases. Your first case is kind of keeping this the same, if you think of that as the positive case. So you always keep what's inside the absolute value bars, ax plus b. You keep the greater than symbol, you leave the value on the other side as it is. And then you have your or, and then your negative case, you not only change the value here to the opposite, but when you do that, you also flip the sign, and that has to do with the fact that when you divide or multiply both sides by a negative, you're switching the sign, so that's why that sign is switching. So you just have to remember that for that negative case, the sign switches as well as making the right side the opposite, or negative. And it gives an example there. So that would be your setup, and then from there you would go ahead and solve it, just like we did yesterday. So the extra step today is you have to go from this form to the compound inequality before you can solve. You just have that extra step of rewriting it. And then if you have less than, it's an and. Now they wrote it this way, so you can definitely jump straight to that condensed form, but you can also just do this exact same thing and just put and here instead. So I could also write it as ax plus b, keep my less than symbol and my c, and then have and then my other one would be ax plus b, change my less than to greater than, and change the c to the opposite of c. So you don't have to write it in the condensed form if you are more comfortable just doing this every single time, but just changing the word that joins them. The condensed form is just that this quantity, whatever's in the absolute value bars, is just in between the opposite of C and then C itself. And they give that example there. I do have one thing that helps me remember which is which, and maybe when you first saw these, you've seen this before, but to remember which one is or, which one is and, I always think great or. So great or, a greater than symbol goes with or, and then less than. So less than goes with and. So great or, and then less than. Because really it's just that word. That's the difference, is which one is joined by or, which one is joined by and it makes a difference which one you have. So if we look at example 2, absolute value of 6y minus 5 is greater than or equal to 13. So first of all, when I look at my inequality symbol, If I'm solving this, I know I need two cases. I see absolute value bars, so I always think two cases. I just need to know if it's or and, so which one would this be? Or. So an or, I don't have an option. I have to set it up as two separate inequalities. So my first one would be I keep the 6y minus 5. I keep my greater than or equal to symbol. I keep the positive 13. And then I have or. And then for the second one, I still have 6y minus 5. But now I flip to have less than or equal to, and I change the 13 to the opposite, so negative 13. And now that you have this set up, it's exactly what we did yesterday. You're just solving both of these for y to write your solution set. So in both of these, to solve for y, I start out by adding 5 to both sides. I'll just do one at a time though. So the first one, if I add 5, I get 6y is greater than or equal to 18. Divide by 6, so y is greater than or equal to 3. And then for the other one, if I add 5, 6y is less than or equal to, and that would be negative 8. Divide by 6, y is less than or equal to, and this would be as a decimal, it's a repeating decimal, so I'm going to leave it as a fraction, but I want to simplify. If I divide both by 2, it's negative 4/3. And then for my solution set, I just make sure that those two inequalities are joined with or. For set builder, I just kind of build that notation around it. So this is one way to write the answer. And then I'll sketch the graph really quickly because I do want to review the interval notation once more. So I'm just going to include my two endpoints. I have positive 3 and then negative 4/3. And so for y is greater than or equal to 3, I'd have a dot on 3, and greater than 3 would be shaded to the right. And then less than or equal to negative 4/3 would be a dot on negative 4/3. Less than would be shaded to the left. So then interval notation, at least for me, it helps to look at the number line. So for this piece, I'm starting from negative infinity, going up to negative 4/3. Infinities always get a parentheses. Negative 4/3 is included, has a dot, so it gets a bracket. And then I have my union symbol. And then the next piece starts at 3 and goes up to positive infinity. 3 is included, so it has a bracket. Infinity has the parentheses. So that would be the interval notation. Okay, questions there? Again, I want to stress, really the only difference from what we did yesterday is you have to go from the absolute value inequality to the compound inequality. So just knowing how to rewrite that, how to set it up. But keep in mind, it's just like those absolute value equations. So anytime you see those absolute value bars, you have two cases. Inequalities just have to be joined by and or. So if we look at example 3, for this one, so we have absolute value of 5z plus 2 is less than or equal to 17. So is this one joined by and or? And less than. So I'm going to show you both ways you could set it up because it doesn't matter to me which way you do it. If you have a preference or one way makes more sense to you. So I could set this up the exact same way I set up the other one. I just write and in the middle instead of or. So my first inequality would be 5z plus 2. I keep the less than or equal to, and I keep the positive 17. And then I have and then my other one is 5z plus 2. I flip the inequality to greater than or equal to, and the negative 7, or the 17 then is negative, or becomes the opposite. Okay, and then I would just like I did in the last one, solve both of these for z. They're joined by and, graph it, write my solution set, and so on. The other way you can set up if it's and, the condensed way, is this really means that this quantity is in between positive 17 and negative 17. So to write that, I would have 5z plus 2. I still have that it's less than or equal to positive 17, but then on the other side, if I read this backwards, it's greater than or equal to negative 17. So you could set it up that way too. But if going straight to this, you're worried about signs being flipped or that's confusing to you, you can definitely set it up this way. Just for sake of time, I'm going to solve this one. But if you wanted to solve this one, you're going to get the same answer either way. In this form, if I solve it, I'm getting z alone in the middle. So I would subtract 2 from the middle and both sides. So I would have negative 19 is less than or equal to 5z is less than or equal to 15. And then divide by 5. So this you could leave as a fraction, negative 19/5. It is simplified, but that is negative 4.8 exactly. Is less than or equal to z is less than or equal to positive 3. And then I'm just adding my set builder notation around it. 3.8, thank you. You're right, because if it was 20, it would be 4. Okay, and then if I graph this on a number line, I'm just going to include my endpoints, negative 3.8 and positive 3. And both would have dots, they're both included. And this notation really shows that z is in between the two. So I can shade in between the two values. And that means for my interval notation, since I have the two endpoints, I'm just going from negative 3.8 up to positive 3. Both are included, so they both have brackets. Okay, questions on that one? All right. I will pass out the assignment and give you some time to work, but I'd like you to go ahead and try example 4, just so at least you're getting one completed that you can check or ask questions on if you're not sure how to set it up. And practice both the set builder and the interval notation. And then I'll pass out the assignment, and during that work time too, if you did have any questions that stuck out to you from yesterday, you could use that time to ask as well, or check the assignments if you hadn't done that.
sort of.
So that means you would have to set it up with the two separate. Yeah, so you did get the right, you did the right outcomes, but the solution of it. This is where you definitely do have to know which one is less than or greater than. Remember, you can make them on your hands if you are worried about being switched. All right, here if you need to check for if you weren't quite done when I was walking around where you didn't have the interval notation, you can check.